All right, so another type of subsidence that you can get is due to the thermokarst. So we're going to go over that in the next few slides. So the first thing I want to do is go over the term permafrost. So some of you may have heard this term before, and it basically means permafrost is going to be the soil or sediment that has been cemented with ice for at least 2 years. So it's not that it's cemented with ice only during the winter and then the ice goes away during the summer. It's going to be at least 2 years for the soil or the sediment to have some ice retained within it year round for at least, again, 2 years. So it has to undergo at least 2 summers of not thawing, basically. So how that happens is basically you're going to get precipitation, and then that water or ice, or not ice, but like snow or hail, is going to thaw enough to become liquid water. That water is going to infiltrate into the ground. Once it infiltrates into the ground, depending on the temperatures, it might continue as just water, as groundwater, or it might freeze to become ice within the pores that it infiltrated through. So if it does that, if it freezes within the soil, is how you get that ice inside the sediment and how you end up getting permafrost. And as long as the temperatures stay cold enough for that ice to remain in the solid form, then you are going to get the permafrost for the whole 2 years, as the definition states it should be. Okay? So you're seeing here a few pictures of places that have undergone this thermokarst. So what happened is that you have the permafrost in the beginning, and then due to warming of the temperatures, that ice that used to be within the soil and the sediment actually does thaw and becomes just water that then runs off. So you have places where there used to be ice, or there's still some ice, for example, this high kind of ridge, and then places where that ice is now evaporated, like this lower part, and then more ice, and then no ice, and so on and so forth. So why is it that I'm saying that the ice bits are probably the higher kind of hills? As you may have gotten the hint before, ice is going to occupy more volume than does liquid water, right? Because when liquid water becomes ice, it just simply expands to occupy more volume. As you know, for example, icebergs are 90% on the bottom and then 10% on top of the surface. So overall, water is going to be more dense than ice, and hence ice is going to occupy more space. There's going to be more volume for the mass that it has. Okay, so hopefully that's clear. And as it occupies more space, it's going to push up that sediment that is surrounding it. So again, what the first thing that happens is that water infiltrates the ground. It becomes ice. As it becomes ice, it's pushing up all of that sediment upwards. So you're seeing that in the first picture is pretty apparent in the soil, in the road. And then you're seeing in the bottom picture, bottom to the left, you're seeing the remains from the thawing process. So you're seeing that a bunch of the ice is actually melted and it becomes runoff, so water that runs on top of the ground. And because there's no gradient in that specific location, they just become big puddles, basically, big lakes, or smaller lakes, I should say, that are scattered throughout the territory. You see in the picture on the right a similar thing, but in this case the ice has melted off the coast, or what appears to be the coast either of the ocean or a lake. And so both the ice thawing and the wave action probably caused this house to, topple over. So it's a pretty serious problem in Alaska, if I'm not wrong, but it happens anywhere where you're gonna get, extreme temperatures during the winter, and then somewhat high temperatures during the summer. So in this slide right here, we have another couple of pictures that show that runoff after the thawing of the ice within the sediments. And you see that water has nowhere to go, and the ground is already too saturated, so the water won't infiltrate and become groundwater. It's just standing there. So that's gonna eventually, if the temperatures are high enough, it's eventually gonna become evaporation, right? The problem is that climate change is exacerbating this thermokarst, is exacerbating the rate at which we are thawing the ice or the frozen soil, the frozen sediment underneath. And it's also exacerbating the rate at which we are freezing the soil in winter. So if you remember from climate change, what is occurring is that temperatures are becoming more extreme. So we're getting colder winters and we're getting warmer summers. And the further you go in latitude, the greater this effect is, or it appears to be. So overall, we are getting slightly warmer winters on average, but the process is that we are getting, cold winters and then warm summers, and those extremes are getting worse and worse overall. So because of that, every time that we get runoff freeze into the soil, we're gonna get a layer of, maybe not permafrost because it might not last a whole 2 years, but what is the same idea of permafrost without lasting. And then during the summer, it's gonna thaw into this runoff that is going to just be stuck, like you are seeing in the two pictures on this slide. So some of this permafrost is thawing at 8 inches per year. So think about that. Some of that soil that is 8 inches, in width, if you would, in depth, it's melting all of it. So it's a huge rate. It's ginormous in my eyes, and hopefully you're seeing that too. And so yeah, so the effects are pretty great, and of course we don't see it here, but they are happening. So here's just a couple of other pictures as examples. You're seeing on the right another road that has been deformed due to the thawing of that permafrost. On the left, you're seeing the permafrost itself that is moving the soil upwards, but you're seeing that it's also melting, and so you see the runoff right below the ice under the soils, the permafrost there. I should clarify this term, frost heaving. So it's going to be the upward movement of the soil particles as that ice is expanding underneath it, okay? Frost heaving. I think that's going to be in your quiz, so make sure you are good with that. And then another thing I should clarify is that the type of soils that are most susceptible to this process are going to be silts, because silts are small enough and light enough for the ice to basically push them up, but they're also going to be a good enough size for the water to permeate through, to flow through them. Clay-sized particles usually don't have the best permeability, although they are too small. However, silt-sized particles are both small enough to be light enough, but also small enough to, or large enough, I should say, to still retain some permeability, some ability for the water to flow through them. Okay? Okay. Sorry. All right. So another way in which you can get subsidence is going to be through the compaction of the sediment itself. So in many places where you get sediment deposition through a wind, which is called loss, you'll see the spelling of it later, or when you have just simply loose sediment that has been deposited by streams, the grains are not going to align very well, and so there's going to be a lot of empty space in between each grain. When you have any water that kind of moves through these grains, it's going to realign them basically, and it's going to shift them around. Well, with that shifting, you're going to get, of course, some sort of redistribution, and whatever structures are above may see the change. As you're seeing in this picture right here, they're comparing the soils on the right, which are the dry and loose sediments that were again deposited either by wind or by a stream that was only like seasonal or something. And then you're seeing that those same sediments are now wet by some water that precipitated, and with that water is able to realign the sediments and put them more compacted, easier for them to not have any spaces in between them. So it compacted them, and due to that, the overall soils just lowered. There was subsidence, right? So that's what you're seeing in that picture. All right, so here you're seeing again that word I mentioned, loss. So that's going to be any deposits by wind, any dust deposits by wind. For the most part, if you think about wind as being the transport medium, those sediments are going to be of small size. So most of the particles that are, transported by wind are going to be clay or sill-sized particles. All right, and those stream deposits in the arid regions are going to be bound with clay or water-soluble minerals. So whenever you do have water running through them, that water is going to easily weather them, and it's going to easily weaken that cement that is holding them together, or somewhat holding them together. So by weakening that cement, basically it's going to cause compaction or completely just dissolution underneath, and whatever soil is overlying it is basically going to collapse on top of it. So you see what you're seeing in this picture on the right. You're going to get the soils to lower and whatever structures are above to suffer the consequences. And the picture to your left kind of shows you that same idea that I was saying about different clay particles. Some of them are not round like you saw in this other slide, but some of them have a kind of rectangular fashion. And in fact, many of the clay minerals have this fashion in which they're kind of rectangular. And once they're deposited, they tend to not deposit in any particular orientation until they are reworked. So they're going to deposit in something like this flocculated fashion, as they're saying. And then once they're reworked by further deposition of sediments on top or by water reworking through the sediments, they're going to become dispersed as this other side of the image is showing you. So ideally, or for the most part, with time and with other mediums, all of the clay-sized minerals that are contained in the clay-sized particles are going to have this fashion of dispersed fashion. And so you're going to see some sort of subsequent subsidence above. So this happens a lot also in swampy areas. It's not the same process, but you can think of subsidence as being soil compaction in the same process. So in organic soils, or in swampy areas where you get a bunch of organic material being deposited, usually you also have water. But when you drain the water from those swamps, of course, there's not going to be any water within the sediments, first of all, so you're going to see some compaction. And then second of all, as the organic matter actually degrades and decomposes, then that's also the volume that it occupied is also going to lower. And so you're going to see further compaction from the soils that are, contained within the organic matter, or however you want to think about it, the organic matter contained within the soils. Overall, the volume is going to change from being with new organic matter and water and soils to just simply being soils and some decomposed organics and no longer having water. So in previous swamp terrain or previous, organic rich terrains, you see this compaction very heavily. And here they're showing you just a couple of those examples. All right. All right. And so they're showing you here that this happens a lot in delta environments. So if you guys remember from, I think it was the flooding lecture, yeah, we talked about deltas, which were this feature where rivers come into their base level and they deposit all of the remains from the sediments that they were carrying, and it kind of makes a delta-shaped letter, the Greek letter delta. And so deltas are going to be big depositional features, and in these features you also get a lot of collapse. So if you think about a big event in which you have remobilization of the sediments into the delta, and then the water pretty much completely drains out into the base level, leaving the sediments kind of inner structure, then those sediments are going to collapse and collapse and collapse. Perhaps not quite far from the mouth of the river, or not the mouth, but the inlet, outlet, I should say. but a little bit closer to it, those sediments are going to collapse and